Well, hi, good morning again. Thanks so much for joining me here in my shop. Oh, I was off to a scary start this morning because my computer that I'm using right now to record this video failed to boot up twice. And on the third try, it booted up. So what that was all about, I don't know, but it makes me nervous. It's just another thing I have to try to keep working. So today, what we're going to do with this radio is we're going to do the alignment on the radio. And we're going to take a look at the schematic. Thank you, Mr. T, for sending me the actual manual, proper printed manual. This is the proper printed manual. Well, not properly printed. This has got all the parts that come from the manual. But there's a lot of problems with this sheet. And I'm going to start off with a drafting issue that's really apparent on this sheet. There's no box drawn around the schematic. And you might think, well, who cares? Do you remember when you were in school and your teacher would look at your work and say, you have not drawn a frame. You have not drawn a frame around the outside of your map or whatever it is you're working on. And you might wonder, why do I have to bother drawing this box? It's pretty obvious where it is, isn't it? It's not obvious. What's not obvious is what's missing on here. If the box were drawn around the schematic, then we would see that part of the box is missing. The part over here. And knowing part of the box is missing, you can then deduce that probably part of the drawing is missing too. But if you don't have a box, you don't have a reference for where the very outside edge, informational edge is. So let's look at the real schematic and see what it really looks like. Okay, so this is page 4, I think. Yeah, page 4 in the manual, and we're looking at the page that has the schematic on it. And lo and behold, what do you see? You see a nice box drawn around it. Now this isn't to make it look pretty or something like that. This is a functional element of the drawing. If you make a copy of this drawing and you don't find all 4 walls of the box, then you can assume something is missing. On my copy that I showed you, the paper copy, the copy ends right here. Okay, so we don't lose too much. We just lose this word red and the fact that the antenna is there. But you might remember that left me deducing that that's what this was. And that's not necessarily going to be correct. Of course, now I have the proper schematic. This is actually a redrawn version. I suppose maybe this whole manual? No, this looks like a typewriter typing, doesn't it? Or does it? You know what? This is not typewriter typing. This is a computer doing this in typewriter-like print. And the reason I know that is because things like the A here are not filled in. Yeah, so this whole thing's been redone. Now these must be the original photographs. It's pretty helpful. Hey, they didn't draw a box around it. And here's let's start with this. Let's go through this thing. It's a nice map of Canada there. National Electrical Service. Yeah, Northern Electric was a big deal here in Canada. 5-tube mantle model. So they're not saying tabletop. I guess I've never seen that. Mantle model must be just a little bit smaller yet. Small enough to fit on your mantle. Superhead service information, specification. 5-tube superhead AC universal. AC universal. A radio receiver. Housed in a table model. Now it's a table model. Wait a minute, it started out as a mantle model, now it's a table model. Molded, it's a Canadian way of writing the word molded. Plastic cabinet, available in 6 colors. Seagrass green, blue, Delft blue. This must be what I have. Delft blue. What does Delft mean? Mine's got kind of a metallic look to it. AM, radio, 455, written in normal size print. There's the tube list. Nothing unusual happening. Oh, AVC. I don't usually talk about this. AVC on the 12SA5 mixer and the IF amplifier. Well, they don't usually bother telling me that. 10, 60 cycles. So this will work in DC. Reverse the plug if it doesn't operate. 30 watts with a 2 watt output. So you can think about modern equipment. You get a 2 watt output probably with a 10 watt input or so. But don't kid yourself. My great big 1975 stereo I have in my office. Probably eats 80 watts just sitting there. Antenna. Built-in loop renders an external antenna unnecessary. Of course, this is a sales thing. If people come in, I want a radio, I don't have to hang an antenna out. Yeah, so here's one. Should one be required? Connected to the red wire at the rear of the set. No ground is necessary. This is another selling point. So they use a loop antenna. There's no benefit or no need for a ground. We use a loop antenna that's built in. Audio system. Audio portion of 12SQ7. So the 12SQ7 is a multi-purpose tube, and it's doing the rectification of the IF signal and first audio amplifier. That's what they're talking about here. Audio portion. Resistance capacity coupled to the 50L6. Well, there's nothing surprising or special about this. Pretty much every radio is done this way. So why they're drawing attention to this, I'm not sure. I don't know why. Of course, the 50L6 is not resistance capacity coupled to the speaker. It's coupled through a transformer to the speaker. There, and talking about the speaker. Controls, dimensions. Here's a picture. Wow, this one's nice and clean. Hey, look, here's a picture of the antenna. Fantastic. Okay, so that's the red wire going out the back. And you can see this wire coming right from the coil, going right to the tuning capacitor. We're going to compare this to my radio right away. Here's that black wire. I thought, no, they couldn't have done it this way. There it is. Done just so. So I think this is just fine. I think this is exactly the way the radio is wired up. Most of the antenna is called T1 for transformer number 1. We'll look at the schematic about this in a moment. Nothing else special in here. It's identifying the trimmers for me, so I can get them in the right order. More trimmers. It looks like there's one on the side here. It might be a little hard to get at. C5, a trimmer here, and C4 on the other side. And C3 here. All on. I think they're all on the tuning capacitor. Underneath, is there anything? I don't think there's anything that has to be tuned or adjusted underneath. Oh, speak of the devil, right there. There he is. So at least one thing has to be tuned from underneath. Alignment procedure. Now, a radio or two ago, I had a radio manual. It was fantastic. Just verbose with information. Some engineer went to town writing it. This is exactly the opposite. This is the kind of alignment instructions where you need to know what you're doing. Dummy antennas. Wire antenna. Antenna wire. Receiver connection. Antenna section gang. Receiver connection. Antenna section gang. Okay, I think I can figure this. It's just a little bit different from what other, like this part. It's just a little bit different. The rest of this is probably fine. Whoops. Order of doing the IFs, and then the oscillator. Two capacitor oscillators. Two of them. One must be in parallel, one must be in series. C4, C5. Antenna trimmer on gang. This is the one I suspect is way out. The antenna trimmer, which is often mounted right on the antenna, is not on the antenna on this radio. It's sitting on the capacitor, on the tuning capacitor. Oscillator lag trimmer. Lag trimmer. Okay, so I don't know what they're talking about there. Again, this was written by somebody who, this is the opposite of a verbose instructions. Totally the opposite. Replacement parts, schematic. So let's check out this schematic here. Again, something I want to talk about is this light and how it's hooked up a little bit, since I think I know how these lights work. And the one in this radio is burned out. So let's talk about that. So people, I've heard over the years that these lights are in the radio doing two purposes. And the story I'm about to tell you, I don't think is true, but this is the story, the common story, that the light helps buffer the tube filament away from the inrush current that's coming in. And this protects the filament inside the rectifier. If this bulb is burned out, then the protection is lost, and you're going to wear this out that much quicker. So you need to replace the bulb quickly. I don't think that's the true story. I think the true story is somebody came up with this way of having a transformerless radio. And they figured it out by simply putting all the filaments in series and designing tubes that all take exactly the same filament current. And that's the case with these tubes. They all take whatever it is. So, you know, there's 12 volts falling here, 12, 12, 50. There's 35 on the rectifier. How come they don't have it in? So they've left the rectifier here. So the question is, if you've got a 6.3 volt light bulb, how are you going to power it? That's the real problem that this thing solves. How are you going to power this light? So somebody came up with the idea, we can put a center tap in the filament of the rectifier tube and draw out a little bit of current to fire up the light bulb, current that would normally go through one half of the filament here. Let's go bigger. So when you first start up the radio, a much larger voltage drop falls across this heater at first. That's how it appears to me. And the light bulb goes very bright from that. And very quickly it dulls down as the current flow in the string drops off and the voltage drop across here drops off. I think this is why the bulb goes so bright at first. Is that saving the filament? Well, it is a little bit, because one of the filaments is actually designed to give you the there's a tap in here. Let me put it, I shouldn't say one of the filaments. There is a tap in the filament designed to produce the 6 volts you need for this light. So if this light is not drawing current, the current that would go through it is now continuing through the filament. So it's a little bit of extra current in part of the filament of this tube. So I think the answer is yes. If you don't have this bulb in, this will wear out a little bit faster. Is it enough to even be concerned about? I don't even know for sure. But I know the word on the street is make sure these bulbs are working to protect this light. So don't know for sure that there's really that much criticality in it. It's really a way to power the light in a radio that otherwise doesn't have any 6 volt source anywhere. So it's a cheat. It's a cheat to get the light on. So that's my story on that. I know there's other stories floating around. That's mine. Now, what do we got up here? That would be of interest. What's going on here? So this is the input. If you want to make use of it, almost have this look like there's a switch. And it looks like there's no connection here, but so I don't know what they're really trying to show here. There's no switch in this radio. So in fact, if you were to plug in your phono here, this seems kind of crazy, doesn't it? Plug in your phono to maybe your iPod today. I'm assuming this is solidly connected here. And what you hope will happen is you'll somehow kill the radio signal coming out of here. Part of that would be tuning the radio off at powerful stations, so the radio is not producing much, because the radio's output is still heading for the speaker, and along with it, it's just picking up the phono here. Unless this is some kind of switch. Occasionally these phono plugs are designed so when you push the plug in, you operate a switch. I wonder if that's the case. Here. Okay, I got a couple things to look at. I'm going to look at this, just for fun, and we'll go back and look at the antenna here. Let me get it on the picture. It's this one over here, isn't it? Right here. Okay. So we have the cut red wire. Yes, I remember that. We have the black wire. Mine loops back this way. Comes up this side. And then have one wire, one actual antenna winding wire coming back to where the red wire is, and the other coming over to the connector, and then two more going to this black wire, which is going to the chassis. That all makes sense to me, because I can see that you've got two coils in here, both of them grounded at this point. One with, you know, this isn't quite done the way. Let's go back and look at the schematic here. I've become very hesitant. So if we look at the schematic carefully enough here, we have the tuning capacitors. There's that series capacitor. I have the tuning, this is a fixed one. There's another tuning. Here, down here is 3 trimmers. 3 trimmers on the local oscillator. 4, another one here. One of these is not a trimmer. One of these is the actual tuning capacitor. Maybe this one, C4. Wow. Well, you know, there's a lot. 1, 2, 3, 4, 5 things to tune here. Maybe this is the reason why this radio doesn't work. All this stuff is out of whack. So if we just follow this carefully, we go around, and then we encounter this. So between here and here are some number of turns in this transformer. It's a little like an auto transformer here, where they have the antenna coming down, feeding through a number of turns, and then a tap drawing off the remaining turns, drawing power, or voltage really, off the remaining turns. No power in this stuff. No power in an antenna. That's the whole problem. No power in the antenna. Somehow you got to get the signal to show up down here with a lot of power behind it. That's the whole deal here. No power in an antenna. Now, any issues here with alignment? So the alignment is going to be these guys here, these little capacitors doing the IF. Oh, look at that. IF can insulated from chassis. So I believe I have seen this once before. So it's insulated from the chassis, but they show it tied back to what has to be the negative bus in here. Yeah, so that's what's going on. So they don't want it on the chassis. In this radio, the chassis is not a friendly actor. Most everything is off the chassis. A little bit going on in the front end here. And, honestly, I don't fully comprehend why they're doing this, but no doubt experience has shown that this is the way to get a quiet radio operating. I suppose this is some kind of noise issue here if you ground this thing right up. I suppose we could. No, we couldn't. I was going to say we could hook this up to the chassis briefly. No, I don't think we should. Okay. Enough looking at this. I'm not going to get any more out of it. Let's do the alignment. Okay, we're ready to get going here. First, I don't think I need the brick right now. We're going to need this guy going. Where's my, I don't need it. Okay, what's he talking about? Who knows? Who knows what he's talking about? Okay, so the instructions say isolate away with a 0.1 capacitor. That's a big one. But hook it right onto the antenna gang. That's the words they use. These things have a mind of their own. Okay. Doesn't say what to do with the other half of the lead. So either half is either going to go on the B minus or onto the chassis. It does not say in here what to do with that. what will we do? Chassis or B minus? Chassis. I just feel a little safer. Look at that right here. Okay. We'll leave the signal off for a minute. Turn it down, and we want this set to 455. 455 in the big print, so that's 455. See? 455. Can't miss that. One of you was pointing out that somebody took the time to write the IF frequency gigantic on this page. So that's what I'm playing off of. Okay. Now we're going to need to listen to the signal coming out. We have two options. One is to listen on the speaker, and the other one is to monitor the ADC going up and down. Let's just go with the speaker. Let's do that. Okay, we'll try my wonky meter here. I have trouble with that meter occasionally. So we want to hook this up to the voice call. Oh, they're sticking right out. Fantastic. Great big honking terminals here. Occasionally one of these terminals will be grounded back to the chassis, and you need to take a look at that. It doesn't look like that's the case here. Because you're hooking up test equipment, and sometimes the test equipment is coming with common grounds between them. There we go. You can see the meter drop off. Before I connected it, it's high impedance, it's an antenna. It's just picking up stuff. As soon as I hook it up, it's got the voice coil and the transformer here, basically killing all the stuff that this was picking up and making the meter go. It's all gone away. Okay, we'll leave that off. We're ready to start the radio. This guy's on. We're ready to start. Just gotta figure out which one's which. Just a quick look at this. No. Yeah, here we are. Right up here. Can you read that? Good question. So this is 11 and 10, that's for sure. 10, 11. Looks like 13, 14. Oh, for crying out loud, I can't read it. We want to start, normally you start on the IF closest to the speaker. And that would be this one. This is the insulated one, this is the second one. So we'll start with this one. My vacuum didn't get all the dust out of it. I think we're ready to go. Okay, let's see what happens here. Power on through the restriction bulbs. Whoop, 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 whoop. Careful, man. She just punched the patient right in the face. I think we're ready. Okay, dim light. There it goes. Great. That hummy sound again. What's that static? I don't know. That's my answer to that. Got a hum I don't like, and let's carry on here. The hum could be coming from a bad rectifier tube. It could be something like that. I can't get rid of it till I deal with the tube. So, but this is all about alignment. Now we got it. That's a funny sound, isn't it? So, what should be coming out of the speaker right now is a tone coming from the signal generator at 1,000 hertz. And amongst all that static, I keep thinking I hear little chirps of that 1,000 coming through. It's probably my imagination. How come I went quiet there? Okay, let's get this signal to come through now. Oh, I gotta hook it up, I guess. There we go. That should weaken any signals coming from the antenna, or virtually eliminate them. It's still got the static, eh? And, you know, we should be hearing the tone right now, but maybe there isn't enough signal coming in. So, I'm going to tune around a little bit. There it is. Wow. Okay, really blasting. Turn it way down. Where'd it go? A little too low. Yeah, no volume control still. Yeah, there's some serious stuff still wrong with this radio. That's for sure. Okay, so it's terribly garbled up too. I can hear the garbling sound. Not a good sign at all. Quiet it this way. Wow, we got lots going on here that's not good. We got static, crashes for no reason, we got garbled sound, and this thing appears to be tuned to 438 instead of 455. So let's see if we can get it to 455. That's way off. So I'm going to start here. Nobody's turned that screw for a long time. This is going to be tricky. First we'll I think I'm going to reach right in front of the camera here. That's where we want to go. Let's see if we can find it. Okay, a little more juice. Baby! Isn't that a surprising thing? A little more this way. That's better. Up, up. Okay, I just barely hear it. Let's bring it back. Bring it back. Bring it back. Come on. And this is a little bit of a bad arrangement here. There we go. Bring it back. We passed a little bit. How about these guys? back my shop volume. Oh. How's that happen? Look at how quiet it went. Holy smokes, that's kind of weird. Come on, meter. Behave for me, would you? Oh, it's taking a lot here to get this stabilized. So, that's a terrible sounding signal to do this with, too. Okay, so I'm going to switch meters. This guy, it just cannot get him to settle down. It's driving me batty. So let's use an even older meter here. We won't have the same problems. I keep trying to give this guy a chance. Keeps failing on the mission. Okay, sorry about the volume control problems here. I'm keeping the microphone levels low to try to keep this from blasting your ears off. Well, that's really, it sounds terrible. It just sounds horrible. In my house, I have discovered that there is a noise signal at about 450 kilohertz, a powerful noise signal. So when I'm working on these radios that have a 455 IF, there's a good chance this interfering signal is present, and that's what we're listening to. There's more going on here, though. There's terrible garbling in here. But let's see if it receives at this point. Maybe that was enough. The IF was quite a ways off. Sometimes when you find the IF off like that, it's because people have twiddled it without instruments, and they've managed to align it, but not at 455. Well, it just makes the dial go wonky. Okay, let's see if we get something this time. And maybe I should put the new light in. Having given a little light speech, let's put a new light in at this point. Holding that in there. This is probably just your basic 47. Yeah, number 47. So I'm going to put an old 47 in there. Old 47. 25 volts. I must have one that says 47 right on it. GE. Boy, that looks right. No, 47. 47. Looks good. 47 goes in. Nice clean bulb. Looks pretty new. I have new ones, but I wouldn't spend a new one on my own radio here. Okay, I think that's in. It gives a chance to see what this really does. Looks like it's supposed to light the red pointer up. Mostly. Okay, we're ready. We're all set. Ready for some noise here. What will it receive? The light is on, but you can hardly see it at this point. It's very, very, very dull. No volume control. Okay. Come on, radio. Okay, 90-degree antenna shift here. Let's go this way. This is the strongest AM station I get here. So see, if I'm looking for it like this, I'll be looking for it for a long time. So 590 showing up at 660. So that can be a sign again that somebody without instruments attempted to align this radio, and having misaligned the IF by accident, they can compensate by misaligning the local oscillator. And you know, with some luck, that can work out okay. But usually what happens is the pointer no longer tracks linearly. So the pointer will line up somewhere on one spot, but be a little off everywhere else. So I mean, ultimately, if you want to listen to, you know, 590 The Fan, the sports station, you could force the radio to tune that signal in well, and pretty much nothing else, just by twiddling around in that. They don't recommend twiddling without instruments. And by the way, you could pick up the local oscillator out of this radio with another radio. If you don't have any instruments, you have another radio, you can find the local oscillator on the other radio. That's going to help you align this one if you don't have any instruments. So wow, so the quality of this radio's operation is still crap. So just continue with the alignment. The next stage is at least it's picking something up. The next stage of alignment could make a big difference in this radio though, and that is 1400 kilocycles. I need a 100 picofarad antenna. We go right on the antenna wire. Oscillator trimmers on the gang, C4 and C5, and then the antenna trimmer. So, and then they have another oscillator down here, a lag one. So yeah, that's a little bit unusual, but then all these radios are a little different. So okay, let's carry on with this part then. 1400 oscillator trimmers on the gang C4 and C5. On the gang. Well, that's not working out. There's two oscillator trimmers on the gang capacitor. One's going to be the antenna trimmer. The other one's an oscillator. So you know what? It has that piece underneath, and on this radio, piece underneath for tuning, almost certainly the local oscillator. It does not appear in this photo. Let me look at this other. Well, let's take a look together. On the photo in here, up here. So on my radio, oh, there it is. There it is, right there. C7. C7. And what does it show on top? It shows C4, C3. Oh, you know what? This is not pointing at trimmers. This is pointing at the tuning capacitor connection. Or is it? Because here's C2 pointing right at the plates here, and C1 pointing at these plates. So we got a 5. That's a trimmer. These are trimmers. This trimmer doesn't exist. There's no screw in there. Come on. There's no screw in my... I'm screwed. I'm screwless. Come on. Really? Only this one should be empty. Well, let's take a look and see. Oh. Okay, sorry, I left the volume down from the last bit there, so I was probably low talking for a little bit. Well, there we are, we're back up. Okay, so let's look at the close-up camera, and we'll see what we can see on this radio here, which I can certainly see what I can see. Okay, so looking from this end, see, there's no screws in the there's no capacitor here to adjust on either side. There never was. What do we got on the other side? The other side, okay, let me just swing around here like this. So there's the two screws there. So I basically have 3 adjustments, but the instructions have 5. Huh. Yeah, I'm kind of frozen here. Well, let's see. On the local oscillator, there's nothing up above here at all. It's just that one down below. Maybe that's all there is. It's just one to do the local oscillator and then one to do the antenna. And too bad for all the rest. No, there's 2 here. 2 here. Think, man. So they called the one local oscillator trimmer a lag trimmer. I'm going to think the one underneath will be the lag trimmer. We'll pretend that this is the oscillator. You don't really have to pretend. So you can see the antenna hooked up right here. So obviously this must be the oscillator side of things. So we'll try adjusting that trimmer and bring the dial into alignment here. We will attempt that. I think 1400 was the frequency they got from Kenneth, isn't it? 1400. Oh, what am I doing? Right, 1400. So we'll go to 1400. This is supposed to go in on the antenna with a tiny capacitor. I have one. Don't I? Well, it won't go quite so tiny. It's a little bigger than what they're saying. Okay, output from the signal generator. Here, output is low. We'll go, again, I don't know what to do. We're going to go chassis. I guess so. Chassis and in. Tune the radio to 1400. Turn down my mic volume again here. Get over there. Oh man, I can't stand this. Okay, I'm going to do a change of plan here. Change of plan. The radio is performing really poorly. There's all kinds of crackling coming out of it. Can't control the volume. So I think what I'm going to do on a long shot, I'm going to test the tubes at this point. I'm trying to hold off on that until I finish the alignment. We got the IF aligned. We know the radio's receiving. Exactly why it's doing all these weird things, volume control trouble, all that, I don't know yet. But I think maybe tubes would be next, the next thing to do. So I think that's what I'll be doing next. Okay, that's it. That's it for today. I gotta get ready for the snowfall. Yes, snowfall. What? A little more volume there too. Yes, snowfall coming, and then rain, rain, rain. It's not a very good day today. Thanks for watching.